In this video, you will learn more about quadratic functions. You will also see some transformation techniques that can be used in graphing curves. Lastly, you will see a graphic organizer that is very useful when interpreting key features of parabolas. In general, a quadratic function is a function that is of the form ax squared plus bx plus c. We call ax squared the quadratic term, bx the linear term, and c the constant. When you are graphing, make sure that your quadratic function is in standard form. It has to be in decreasing order in terms of its degree. So if you look at the degrees of the x variable, this is 2, this is 1, this is equivalent to c times x to the 0, but x to the 0 is just equal to 1. So the degrees of x are arranged from highest to lowest. When the value of b is 0 and c is equal to 0, and a, which is the coefficient of x squared, is equal to 1, you get the parent quadratic function, which is f of x is equal to x squared. Previously, you were asked to graph the parent function by completing a table of values from -2 to -1, 0, 1, and 2. And when you got the values of x squared, all you needed to do was square each number. So when you square -2, you get 4. When you square 1, you get 1. Square root of 0 is 0. 1 squared is 1, and 2 squared is 4. So notice that the values repeat themselves because when you square a negative number and a positive number, their answers are the same. The square of +2 and -2 is equal to 4. When you graph these table of values, you saw that the parabola is actually a curve that is opening upward or facing upward, and it has its vertex at 0, 0. The axis of symmetry is the line that cuts your parabola into two equal halves, and the axis is given by x is equal to 0. So there are a lot of patterns that you must remember when you are interpreting key features of parabolas. For example, the axis of symmetry is always x equal to a number, and that number can be found by looking at the x coordinate of the vertex. Also, since the value of a is equal to 1, which is positive, your graph is opening upward. If the graph is opening upward, its vertex is actually the minimum value, so it's the lowest point on the graph. The vertex is also important because it gives you a clue as to what numbers you will use for the axis of symmetry and the range. So the axis of symmetry always follows the x coordinate of the vertex. That's why it begins with x equal to. So the axis of symmetry of your parent function is x equal to 0. On the other hand, the y value of the vertex gives you a clue in writing the range. The range is the possible y values, so it always begins with y equal to. So since you're using y equal to, you take the y coordinate of the vertex. In this case, it's 0. So that means the vertex is 0, 0. The x coordinate is 0, so that means the axis of symmetry is x equal to 0. And since the y coordinate is 0, the range is y is greater than or equal to 0. Now, what happens when the value of a is no longer equal to 1? So let's say, for example, it's 2x to the second power, or 1/3 x to the second power. The value of a gives you a clue as to what transformations are happening to the parent function in order to come up with a new graph. The first thing you're going to look at is the sign. Is a positive or negative? If a is positive, you know your parabola is concave up. meaning it's opening upward. But if a is negative, then your parabola is concave downward. So if a is negative, we say that the graph of f of x is equal to a x squared is a reflection of the graph of x squared across the x-axis. Now let's look at the value of a. If the value of a is a number that's greater than 1, then it means there is a vertical stretch. We say the graph of f of x is equal to ax squared is a vertical stretch of the graph of f of x is equal to x squared. But if the value is a fraction that is between 0 and 1, let's say for example 1/3, 1/2, or 0.5, 0.3, then we have a vertical shrink. We say the graph of f of x is equal to ax squared is a vertical shrink of the graph of f of x equals x squared. Now I'm going to show you an example on how to use the graphic organizer in graphing monomial quadratic functions of the form f of x is equal to ax squared. For example, graph g of x is equal to 2x squared. The first thing that we have to do is to write down the parent function. So the parent function is given by the same table of values that I showed you earlier. Now, if you look at the function, the original x squared is being multiplied by 2. So how are we going to create a table of values for the new function? You will multiply the same number here to the original values of x squared. So that means you will have a new column for y. These numbers are the same as the original x. Well, these numbers are the results when you multiply the original y value by 2. So if you multiply these by 2, the results would be shown here. Now that you have the new function, you can describe the transformation that's happening to your quadratic function. Since the value of a is 2 and it's greater than 1, then we say the graph of g of x is a vertical stretch of the graph of f of x is equal to x squared. Lastly, let us look at the key features of the graph of g of x is equal to 2x squared. So the vertex is 0, 0. You can find that in the middlemost part of the table. And since our a value is positive 2, and the graph is opening upward, the vertex is the lowest point, so we call it the minimum. The axis of symmetry is x is equal to 0, and the graph is opening upward with domain all real numbers. The range is y greater than or equal to 0. Notice that you can fill this out even before you graph your parabola. Just by knowing the value of a, you can tell whether your graph is opening up or down. And if it's opening upward, then that means the vertex, which is the middlemost portion of your table, is actually the minimum point. Once you have the x and y coordinates of the vertex, that will give you a clue as to how you're going to write your axis of symmetry and your range. So x is equal to, take the x coordinate, and then y is greater than or equal to, take the y coordinate. So when is this greater than or equal to, and when is it less than or equal to? If it's concave up, then the range is greater than or equal to it. Now these values are also the x coordinates of your vertex. So the behavior of the graph is increasing when x is greater than 0, and it is decreasing when x is less than 0. These two portions at the bottom can be easily verified once you have the graph already. So you can tell that the graph is going up when x is greater than 0, and the graph is going down from left to right when x is less than 0. If you notice, these two signs here are, somehow matching. So if this is y greater than 0, then the interval for which the graph is increasing is x is greater than 0. And then, of course, the other direction is when it is decreasing. So I hope you find this graphic organizer helpful in graphing. So go ahead and graph this table of values so you can see the actual shape of your parabola. Okay, now let's take a look at this example. In this example, the value of A is negative. So if you remember, I said earlier that if A is negative, then the graph is reflected across the x-axis. Now, the value of A is 1/3. In decimal, that's equivalent to 0.3. And since this decimal is between 0 and 1, then the new graph of h of x is a vertical shrink of the graph of f of x equals x squared. Now let's look at the table of values. For the parent function, you should know this by heart already. Some students just use the middle three pairs from -1, 0, 1. Okay, that will give you the shape of your parabola already. You have the vertex, and then you have two ordered pairs, one on each side of the vertex. So if you don't want to use from -2 to +2, you can use -1, 0, and then 1 only. Okay, so how did I get these values? I multiplied all the original y by the value of a, which is -0.3. So if you multiply 4 by -0.3, you will get -1.2. 1 times -0.3, you'll get -0.3. 0 times that is 0. 1 times -0.3 is again -0.3, and then this will definitely be -1/2. Now let's look at the key features. Your vertex is again 0, 0, but since our graph is reflected across the x-axis, it's now opening downward. So that means your vertex is the highest point or the maximum, and we say that the graph is concave down. Now the axis of symmetry is x is equal to 0. Domain is all real numbers. Since our graph is concave downward, we now say less than. So your range is y less than or equal to 0. And last but not the least, the graph is increasing from left to right when x is less than 0, and it's decreasing when x is greater than 0. I hope you found those two graphic organizers and some examples helpful. In your next task, you will be, filling out a similar graphic organizer. I changed the functions here so you can practice graphing. All right.